Hello everyone, my name is Yurixy Bugarin and I'm from Mexico. It is a pleasure to present to you my master's project on the topic 3D printing to produce model food structures to study food oral processing. The project was hosted by the Safe Food Lab, a research team between INRAE and AgroParisTech in Paris, France. In this study, it was demonstrated that 3D printing can be used to create controlled product structures made of starch. The yield points of the 3D printed structures were strongly affected by the change in external dimensions and porosity. About 50% reduction in the pressure needed to yield the structures was observed when wetting of the 3D printed structures was performed simultaneously to compression. To achieve this, we conducted a 5 steps methodology, where we perform a rheological characterization of our ink to evaluate its flow during printing and yield stress. Consequently, the structures were printed followed by a geometrical analysis to measure and compare the 3D printed structures with their target dimensions. Afterwards, we proceed to its respective analysis to assess its mechanical and/or dissolution properties. But why did we do this? Because we wanted to understand the relationship between food structure, food oral processing, and food texture in mouth, which is important to develop novel food products addressing the specific demands and needs of senior consumers. To develop novel food structures, food research should assess and optimize new manufacturing processes, such as 3D food printing. This process consists of a 3-axis stage, an extrusion unit, and a user interface. 3D food printing is characterized by a high degree of control, enabling the design of novel food structures and can become an important research tool to study the relationship between food structure and food properties in mouth. To optimize this process, the following factors should be considered: the deposition process of the printed ink, the capability of the material to build stable structures, and the strength acquired by the printed object to resist mechanical treatments. Therefore, the objective of this work were to evaluate the feasibility of 3D printing to produce model food structures designs. Also, to study the effect of these designs on the structure's mechanical and dissolution properties. In conclusion, the development of novel food structures has a great potential as a research tool to understand the link between food product structures and perceived texture, but also to foster the development of novel food products to satisfy the specific consumer needs.